divergence theorem, which is this guy here. This is a copy of a previous page, so it's the same information. Last time we did the situation where E was described Cartesian, right? X, Y's, and Z. Boxes are good examples of that. What we're going to do now is we're going to move over to questions where cylindrical coordinate scheme is much more useful. So they're all the same. Find this guy here. Here is your vector field, and this here is your surface. And this surface is going to be created, it essentially encloses a volume that's going to be called E. Where is it? There you are. And we do a triple integral. So I'm going to find the divergence of F first. And it's this guy plus this guy plus this guy. Of all the things we've done, I think the divergence is one of the easiest things to see and do. Okay, if you do that with x's, you get 3x squared y. If you do this with y's, you get minus 2x squared y. And if you, I think there's a z in that. Let me check. Question 9. And there is. I thought there might be. And if you did this third one with respect to z, you get that. And a very interesting answer happened. Can you see why this question is now going to be very simple?
Integral of 0 is 0, right?
Yeah, so I really don't care what E is now, because the triple integral of the number 0 with any cylindrical, spherical, or any other coordinate system in the universe is still going to be a big fat 0, isn't it? But let's pretend for a minute that it wasn't 0, right? It was something that we had to deal with. So let's just use this question as practice on what this might look like. If you were looking at this shape, right, and you wanted to know what would this surface look like if it got sliced at 2 and at -2. So you imagine you took this surface and you sliced it at a height of 2 and you sliced it at a z of -2, what would it look like? Well, if you plug in one of the bounds, which is -2, right, you would get x squared plus y squared, essentially take away 4 equals 5. And if you plugged in z equals 2, you would also get 5. So essentially, this thing would be polar. And therefore, I could use cylindrical coordinates on it. So what would that look like? It would look like r equals 0 to the root 5. Theta would equal 0 to 2 pi. And z, well, we've already got the limits of z. That would have been E. Are you comfortable how we would have got E if we needed to have calculated it, right? This shape here, if you imagine what it would look like, I mean, I could put it into, you know, the thing and draw it and slice it and look at it. But basically, it looks like the way it's cut on the floor, the XY plane, it's a circle. And that's this bit. And then this tells me Z is 2, Z is -2. So that's what I would have done if I had to do it. I didn't need to do it because we already got the answer as 0. So the moral of that story, which is what I'm going to try and make sure I do from now on, is shouldn't we find the div of F first before we start working on getting E, in case we didn't need to in the first place? Right, here's a new one. Question 10. All the questions we're going to do until whatever it is, 20 minutes from the end, they're all going to be cylindrical, right? So this region E is going to be done with cylindrical coordinate system. And so you might think to yourself, how do I know that? Whenever the surface has an x squared and a y squared, and especially when they are the same sign, doesn't that tend to generate circular things when you project it on the floor? And so that's why it's a good candidate for that. So the divergence of this fella I know this isn't going to be 0, but I'm trying to be consistent now. That guy gets you 2x. That guy gets you x. And that guy gets you 1. I was surprised by what you get out of diff f. It could be anything. 2x. Y gets you an x. Z gets you 1. Okay. Not a very difficult thing to integrate. Okay, let's focus on this information here now. If you take this guy and the xy plane, which is essentially, isn't that just another way of saying z equals 0? Let's see what the floor looks like. Right, so I'm projecting this onto the floor. And when I project it onto the floor, what do I get? I get 0 equals 16 take away x squared, take away y squared, which basically gives me a circle, radius 4. So there we go. Now, what about z equals in the plane? Well, won't that be z equals? And this fella here and this fella here, well, one of them's 0, so I'm putting that there. And this guy here is going to be 16 take away r squared. Are you happy about z equals 16 take away r squared and z equals 0? Right, the bit that goes here. Are you okay with that? So this is essentially E. Right, we have the limits integration. So we are going to do a triple integral. And we're going to go from z equals 0 to 16 take away r squared. And we're going to go r equals 0 to r equals 4. We're going to go theta equals 0 to theta equals 2 pi. The div of f, which is 3x plus 1. Since we're going cylindrical, it's going to be, yeah, I guess I should do it in this order. dz r dr d theta, because z's going to be first. What's the only thing I haven't done here so I can continue with this question? What's the one little thing that I've still to do?
Convert the integral to polar, or not polar, but effectively polar.
Yes, they are theta stuff, right? So don't I have to turn 3x plus 1? Now 3x plus 1 is not very pretty, but x is r cos theta plus 1. So can you imagine that being in here? So we would end up with an integral that looks something like 0 to 2 pi, 0 to 4, 0 to 16 take away r squared, 3r cosine theta plus 1, do a dz, do an r dr d theta. Is this variable separable? Correct. I see shaking heads. Isn't it because of this guy? So if you want to do this fella, basically you just tag a z on, don't you? So it's going to be 0 to 2 pi, 0 to 4, 3r cos theta plus 1 z evaluated at z equals 0 and finishing at z equals 16, take away r squared. And then you can do an r dr d theta. Okay, I'm going to stop there. Would you agree it's just messy and ugly, but you'll eventually get an answer? Are we good with this? So I will move on. Sure. My next question is hiding, but no, I've got one set up. Stick them over there. The done pile. Probably under here, knowing me. No, where are you hiding? No, I've got one more question. Where did I put you? There we go. No, I had it. That was question 11. Next guy in town. Question 14. Now, question 14 is cylindrical, but we're going to do something I don't think we've done yet in cylindrical. So we will do this question, but I want to kind of show you something to do with polar. I should say cylindrical, but yeah, polar, cylindrical, they're almost interchangeable. When we typically do cylindrical, isn't the circle on the XY plane? And when that happens, X is r cos theta, Y is r sin theta, and Z stays as Z, and we get some version of, depends on the order, r dr d theta dz, right? And that's what dv is. And we almost just take it for granted, right? That's how you do cylindrical coordinate system, right? But there are some situations that lend themselves to cylindrical, but whose orientation are not on the XY plane. Can you imagine a situation where, oh God, it's hard to draw. This circle is stuck on the XZ plane. Now, if the circle is stuck on the XZ plane, for instance, you can adapt the cylindrical coordinate system to take account of that. So when you're on the XY plane, right, Z is the guy that's on its own. If you're on the XZ plane, Y is still Y, right? The variable Y doesn't change. It's still Y before, it's still Y after. The other two become r cos theta and r sin theta. And if that picture didn't work, this probably won't work either. And if you do it on the YZ plane, so can you imagine that the circle is on this wall here? Like this wall here. When you do that, the guy that stays put is the X. And the other two become r cos theta and r sin theta. So we typically think of cylindrical coordinates as being the projection of the shape onto the floor, because that's the most common direction that you do have cylindrical coordinate system. And when we do it, we get this. But you can see here that each time you change your orientation, then the formula has to adapt, right? Do you see how this one's now going to have a dy, and you're going to have an r dr d theta, and this one's going to have a r dr d theta dx. And so they are all versions of cylindrical coordinate system.
So in the last one, it says y equals r cosine theta, y equals r sine theta. Should
One of them should be a z.
Okay.
Yeah. Why don't we have 3 flavors of spherical?
Because it's a sphere is symmetrical in every direction.
Yeah,
Right?
so it really doesn't matter. Exactly. But doesn't a cylindrical, think of a cylinder, right? A tin can going forever. Doesn't that have an orientation, right? You can go in the x-axis direction, the y-axis direction, or the z, which is essentially what these are doing. You're going this way. You're going that way. You're going that way. Actually, I wish I've drawn that instead of the pictures I just did. Can you see that the cylindrical coordinate system has 3 orientations, and these reflect it? This one is the XY plane orientation, and this one here is the XZ orientation, and this one is the YZ orientation. Okay, after all that, it was just to set this question up. So I'm going to find the divergence, and it's differentiate with respect to x, then y, and finally z. And you do this with x, you get 3y squared. You do this with y, you don't get nothing. And you do this with z, and you get 3z squared. And I'm going to call this 3y squared plus z squared. Okay. Now, this is your surface. If this had said x squared plus y squared equals 1, and z goes from 2 to -2, wouldn't that just be a cylindrical coordinate system? You wouldn't think second thing. You wouldn't give it a second thought, right? Do you notice it's not x squared plus y squared, but y squared plus z squared? So what does that tell me? It tells me that you are looking at a circle, but it isn't on the floor. Isn't this a circle on the YZ plane? So the x's are going to go from -1 to 1 because of this. Actually, I wish these weren't 1. I wish these were some other number. Let's change the question so it's a little bit less distracting, right? Because it could be anything. Right, 4 to -4. Boom. You're then going to do a circle radius 1. And I have now described what that surface would look like. Are we good with that orientation and how you can adapt the cylindrical coordinate system? Now, what will y squared plus z squared equal in the coordinate system that we're now using? Well, if you think of y as r cos theta and z is r sine theta, then won't y squared plus z squared just be r squared? So this will be 3r squared. Be comfortable about that? Any questions? Okay. So we are ready to set up the calculation necessary to find this surface integral. So this guy, according to the divergence theorem, is this triple integral. We're going to call this guy well, I guess I could do it in any order I like because they're all numbers. So how about x equals -4 to x equals 4, r equals 0 to r equals 1, and theta equals 0 to theta equals 2 pi. And the divergence is 3r squared. And now the only thing I have to be careful about is what dv is going to be. Now the orientation of this particular one, can you see it's that guy? Wasn't this a YZ plane cylindrical? And in a YZ plane, X stays put. So what you're going to have is a dx, an r, dr, d theta. Now in this case, you've got theta equals 0 to 2 pi. You've got 0 to 1 again. You've got -4 to +4. Wish I'd done this earlier, but it's too late now. Is this one variable circle?
Yes.
Right. So how about a 0 to 2 pi of 1? A 0 to 1 of 3r cubed. And a -4 to 4 of 1. Right, this guy gets me 2 pi. This guy gets me 8. And this guy gets me 3/4 of r to the 4, which means it gets me 3/4. And that gets me 2, and that gets me 6, and that gets me 12. So it actually came out quite nicely. Are we happy about that question? If we're okay, I'll move on. Thumbs up, we're okay. Of course, the vast majority of cylindrical, isn't it z that stays put, and x is r cos theta and y is r sin theta? But that was a good question because it wasn't that. So, kind of like. Not going into all of question 11. Not 11 anyway. I changed my mind here. Which one am I looking at? Right. Going into just setting up the limits of integration, because finding the div is pretty straightforward now. So this is the surface S in question 11. It's made up of that which we recognize as a cylinder, and it's also made up of this guy and this guy, right? Now, in this world, can you see why this is going to be cylindrical coordinate system? Isn't the clue x squared plus y squared equals 9? Isn't this back to normal reality, the ones that we're used to? So what does that give me? It gives me a circle, and it gives me an r then. It goes from 0 to 3. It's a full circle, so theta goes from 0 to 2 pi. That's theta. And z goes from 0 to x plus 5. Well, sort of. Wouldn't that be the limits on Z? Because when you do cylindrical, aren't you only allowed r theta, and in this situation, Z? Right. So that's that one set up. Only the E part. That's what the solid looks like. Let's look at 12. Same problem. I have this guy and this guy. And I want to figure out what E is. So it's this guy. Oh, we've seen this guy tons of times. Doesn't this guy look like a bowl going upwards? And if I drew this guy, wouldn't he look something like this? Right, this guy here. Now, if you're not sure, you should put the thing in and look at it. If you did Z equals 4, can you imagine Z equals 4 would be a horizontal plane? And can you imagine that when these two meet, you'd make a circle, wouldn't you? And so the region that we're interested in, right, the 3D region is going to be x squared plus y squared equals 4. So that gets me the r and the theta. And now I'm going to do a mistake. And you might think, oh, I know what your mistake is. You should have did that. But that's actually not my mistake.
Flip them, right?
Yeah. Why? Because that's right. You flip them. But why?
4 is the upper limit for
Yeah.
Z, right?
Yeah. The surface that we're talking about is down here. So it's from that guy, the flat guy, he's high and he's low. Now, if you put it into some of the software, couldn't you just draw the thing? Because I guess sometimes you're not sure who's the high guy and who's the low guy, right, for the Z limits. But if you put it into the picture, you'll see the flat line is high and the surface is under it. Right. Okay. Could do that, I guess, but that wouldn't be a circle, so if it changed my mind on that, no. Oh, I could have done that. That might have made a difference, right? Yeah. So what would have been the difference? Well, you'd have got the answer 42, but the right answer would have been negative 42. So if you know that you got the right numerical answer, it might simply just be that you didn't flip them round right, especially the Zs. Where are we? Time. Right. There are two examples of the divergence theorem using spherical coordinate system. If you use cylindrical, where you see x squared plus y squared, right, you see circular objects in the surface in some way or another, then when will you use spherical coordinates? They're actually a lot easier to do, because don't you only use spherical coordinate system when the solid shape is a circle, a sphere, or part of a sphere? So you kind of know it, because it'll say, well, let's show you what it says. This is question 15. You've been asked to find the usual flux thing. And in this case, what are we told? We are told that S, the surface, is a sphere, radius 3. Would you agree there's no real confusion there? It's a sphere, which means it's going to go spherical. Now, what else do I know? Well, in this question, I also know that this guy is x cubed plus y cubed. This guy is y cubed plus z cubed. And this guy is z cubed plus x cubed. I should find this just in case that damn thing is 0, which I highly suspect it's not. But just in case, to try and be consistent, I'm going to find the divergence first. This guy gets you 3x squared, then you get 3y squared, then you get 3z squared. And I'm going to pull that out as 3x squared plus y squared plus z squared. In the spherical coordinate system, what does x squared plus y squared plus z squared simplify to?
R cubed.
Wind the power down.
Is in a row?
R squared. The equation of a sphere in 3D space is x squared plus y squared plus z squared equals r squared. You might think it should be r cubed because it's three-dimensional, but it's not, it's r squared. So would you agree that div is looking good? Now I've just called it r, and I've just realized a little notation thing. Don't we call it rho when we talk about it in spherical coordinate system? Okay. Now, let's describe a sphere. Well, there are a number of variables. There's rho, which is essentially the radius guy, and that goes from 0 to 3. There is a theta, and there is a phi. Theta goes from 0 to 2 pi. What does phi go to?
Pi.
Yeah. And that's just something you have to write down or memorize or whatever. So we will be able to get our guy. He's going to be the triple integral of the sphere, divergence of f dv. But that's going to become, since they're all numbers, I guess it really doesn't matter too much. I'll do 0 to pi, 0 to 2 pi, 0 to 3. The divergence is 3 rho squared. And I'm looking it up as well because I don't want to screw this up. What is dv in the spherical coordinate system?
Isn't pi? Oh, sorry. Rho square sine phi.
Rho squared sine phi. I've just realized I'm writing that guy, and I should be writing that guy, but that guy and that guy are the same guy in my world. So, and then you just tag in the guys that go later. So what's that going to be? A rho squared, a sine of that, and I'll just call it dv because I don't have enough room. Would you agree that this is going to be variable separable? And if we do, right, so we're going to do phi equals 0 to pi, and that can get the sine. Poor theta doesn't really have any contribution, so he gets 1. And this guy is 3 rho to the 4, I believe. And can I just dot that again? Would you get it's not that hard to do? I love variable separable. Don't they just make your life so much easier when it comes to finishing a question off? The ugly ones are where you have to do, you know, this one and then it changes and then you do, oh God, who knows, integration by parts or something that takes forever in a day. So I like elegant and smooth. Are we good with the one of two examples of spherical? I'll move on. The last question, and we have finished, is this is a vector field. 8x cubed, oops, with a z. 8y cubed with a z. And 6z to the 4. And the surface S is a sphere with radius, capital R. Okay, find the divergence. If you differentiate this guy, you get 24 x squared z. If you do this guy, you get, let me check that guy. You get 24 y squared z. And if you do the last one, you get 24 z cubed. Now I'm going to pull out 24z, and that leaves me with x squared plus y squared plus z squared. Has anybody got handy, and I'm having to look myself to be honest, what z looks like in the spherical coordinate system? I have it in front of me, so I'm being honest.
Isn't it just Z?
That would be if it was cylindrical, yes, but this is spherical.
Oh, yeah.
No matter if you get it wrong, I couldn't remember it either. I had to make sure, so I looked it up. Do you think there's
cosine phi.
Did you look it up, or did you actually know that, or figure it out, or guess it, or whatever?
I had a file. I had to go through my Rolodex and find spherical in my head.
Yeah. Do you know that's what you're going to do in the final, right? When you hit something like
Yep.
that, right? You're going to go to your notes or your file effects, whatever way you do it. And that means that this fella here is now going to be rho cosine of phi, still times a rho squared. So what's that going to be? Okay, that's pretty good. Let's do the region E now. Well, since it's a sphere of radius r, that's pretty standard. Rho then is going to be from 0 to capital R. Theta is going to be from 0 to 2 pi. And phi is going to be from 0 to pi. Now you put that package together, and our triple integral of region E of the divergence is going to be in no particular order. Rho equals 0 to rho equals capital R. Theta equals 0 to theta equals 2 pi. And phi is going to equal 0 to phi equals pi. Why did I not care about what order I decided to do those three variables in?
Variable separable.
Well, that's certainly true. You're right.
They all have numbers and no
They
variables.
all have numbers and no variables, which is what Chris is saying as well, in his way as well. That's nice. I like things that make things simple, and that's nice that we can do that. Now, the guy that's going to be in here is going to be a 24 rho cubed cosine phi. So in the order I've written, it's going to be a d phi, a d theta, and a d rho. And they are separable. So it's going to be 0 to capital R of 24 rho cubed. Looks like a K, but it's a capital R.
Do we need the
Keep talking. Do we need what?
do we need the sine phi rho squared in the DV?
Darn it in space. Well caught.
Okay. I was like, wait, did I
Wait,
miss?
yeah. No,
already?
you're right. And I actually, did I write that down? No, I didn't. Okay. But we do need it. So we should have also put in the rho squared sine phi that goes in there. So that means this guy gets 2 more rows. Poor theta is stuck on his own. And the phi's, well, what do the phi's get? They get a sine and a cosine, really. I'm not going to finish this question. Would you agree that's just an ugly power rule? That's just 2 pi. Okay, how are you going to tackle sine theta, cosine, sine phi, cosine phi?
U sub?
Yeah. And does it matter which u sub?
Not really.
Nah, not in this case. And that's probably how I would have done it. Excuse me, there is another way I could have done it. Couldn't have recognized it as an identity, a half the sine of 2 phi, and did it that way. I don't think it was quicker,
Yeah.
it's just different. You know, I'm not saying it's the right way to do it because I don't think it is. I don't think it's the wrong way either. Trig does that sometimes. Can you do a trig question more than one way? In this case, you could have done a u sub sine theta and it would have worked. You could have done a u sub cosine theta and it would have worked, or you could convert it to a half sine 2 phi and it would have worked as well. So, whatever the answer is, it's going to go in there, or whatever that answer is, it's going to go there. I know what this answer is going to have. Isn't it going to have powers of capital R in it because of this limit? And you plug it all together and it is over. Got a few moments. I want to show you something. So while I'm doing this, you can all say hi. We have got, I think it's a really cool video. One of our students has given it to me. If that student does not mind me mentioning them, you will say your name. Otherwise, it will just be a student and I'll be fine with that. You want to take credit for it, the person who sent me the video.
It was me.
Okay, he gave it up. Didn't need to, give him the choice not to. There is nothing in this that is going to help you with your exam, but it was so cool I wanted to show you. Oh, what was that? It's not the International Talk Like a Pirate Day, Lindsay, is it?
Well, I don't know. Christopher was repping pirate speak in the chat.
No, I just decided to say that.
Christopher, since you're the instigator of this, I think we should hear your pirate.
Hold on. I gotta get into character.
Okay.
Arr, ahoy me hearties.
That's pretty good. Thank you, Christopher.
Okay, Chris, I have a pirate joke for you. I was going to show you this cool video and go and watch it. It's a really good one. It's about, I believe he's English, but I won't hold that against him. But he does say Z. So anybody who says Z is good in my books. But this is my pirate's joke. This little boy was absolutely, you know, like kids like dinosaurs. This little kid loved pirates, loved them. And he was walking along the beach one day with his mum. And in the distance, there was a real pirate. You know, the classic movie pirate. Peg leg, parrot on the shoulder, hook, patch, the lot. And the little kid breaks away from his mum and runs up to the guy and he goes to him and he says, "Are you a real pirate?" And he goes, "Arr." He says, "Yeah, I'm a real pirate." The little kid looks at him. He looks at him. He says, "How come you've only got one leg? How come you've got a peg leg?" And he says, "Well, he says, I was out at sea one day and there was a big battle and a cannonball blew me leg off and I've got a peg leg." And the little kid went, "Wow, that's cool." And the kid looks at him and he says, "How come you've only got one hand? How come you got a hook?" And the pirate says, "Well, I was out at sea one day and there was a big battle and a cannonball blew my hand off and I got a hook." The little kid goes, "Wow." And the little kid looks at him and he goes, "How come you've only got one eye? How come you've got a patch?" And the pirate went and said, "Well, I was out at sea one day and a seagull pooped in my eye." And the little kid says, "You don't lose your eye just because a seagull pooped in it." And the pirate says, "You do when you forget you've got a hook."
That was good.
That's a good one.
Anna, you are shaking your head at me. Will you? Come on, that's a good joke.
10 out of 10 on the story itself.
Okay. Actually, we do have a few.
That was good.
Right.
That's perfect.
Let me just show you what I was going to show you after all, right? You should all be looking at this. There's a guy down here, Navia Stocks here, and I put a video up. And this guy is just, I mean, he's weird looking, but he is, it's in a nice way. Look, he's even got a tattoo of this bloody thing on his body. And this is the fundamental equation that I believe is used in fluid mechanics. And the cool thing about it is that when, well, I can zoom through it because there's 20 odd minutes, but he writes down some stuff and talks about how what we've got here. Have we got to the equation? I'm just trying to find a bit where he does an equation here. It's really interesting. Can never find it when you want things. There we go. If you look at this equation, do you see a little idiosyncrasy? Do you see that line under the F? Do you know that's another notation for my line at the top
Your
of the arrow?
screen sharing isn't on.
Oh, darn it in space. Can you see it now? No.
Not yet.
Not yet. How about this? Can you see it now?
Yay!
Yay, okay. Let me show you the weird guy again. He has a tattoo. I mean, if anybody thinks all mathematicians are geek looking, that guy looks like he's a roadie for a rock band. I mean, he does not look like a classic mathematician, but look at the cool stuff. You recognize our operators? And do you see that little line under the F? That just means it's a vector. I don't know, it must be an English notation. It's not in notation averages, but whatever. And it's a cool video. It tells you all about fluid. Family story. One of my many, many nephews, and I have lots, but one of the few who's actually not in Scotland. He's in America, married an American woman, but like me. He got his PhD in fluid mechanics. So I bet you if I showed him his video, he would know all about it. He is making an absolute fortune. I am as jealous as heck of his money because he works for an oil company. So you can imagine what a research scientist must be making when you work for an oil company. He bought his own house after 3 years. I mean, bought it. I mean, not a mortgage, just bought it. So, God, the money he must be making. He hasn't sent me any, so I'm not so sure I like that part. But you can make money doing certain sciences. So if you want to make a lot of money, get a job in the oil industry. Actually, probably not the way the politics are today. They probably want to do away with the oil industry eventually. But what would you get a job in? Solar power. Get a job in solar power. Well, that's us. tomorrow you are going to have some really good questions for me, because tomorrow we're revising for the final, for the test. Can we do homework question 2? Whatever it is, you bring it with you and I'll do it. Okay, so bye-bye, guys. See you tomorrow. I'll hang about for questions.
Have a good day.
Thank you, Professor.
Thank you. You liked my pirate joke, Anna? Oh, she's gone. Did you like my pirate joke, Lindsay? Travis, I know, liked it.
Yeah, I thought it was quite good.
What about you, Brooke? Did you like the pirate joke?
It was very good.
No, okay. And it only came to me because evidently today is Talk Like a Pirate Day. I think I talk quite well as a pirate because the Scottish accent rolls the R's. And I think pirates like to do that as well. Arr, Jim lad, like that. So, evidently. Right, who have we got as a question? Who wants to start the ball rolling?
I can. It's in 16.5. It's question number 9.
Okay, 16.5, number 9. Is it something you can write? Tell me and I'll write it down. Otherwise, I'll go looking
I'm
for
just
it.
trying to find the curl of f, and f is the natural log of x, comma, the natural log of xy, comma, the natural log of xyz.
I would do something algebraically before you start doing the curl.
Because in 6.5 it asks for the curl and div of the function.
Okay. Oh, you can't see what I'm writing, darn it. Let me show you. The algebra that I was talking about that would be a good start to this question is to realize that this can be written as 2 logs added and this can be written as 3 logs. So that when you're setting up your IJK and then your all this stuff, they have a log of x plus log of y, and a log of x plus log of y, plus log of z. Now, if you do it that way, I think you'll find differentiating a lot easier. If you try and leave it like this, it will eventually come out as the right answer, but you may have made a mistake in it. So
sometimes you can forget that you can write natural logs as added together when they're multiplied.
Is that maybe all I need to do for you right now, or do you want me to keep going?
I totally forgot that I could rewrite natural log of x times y as natural log of x plus natural log of y.
Okay, so this question now becomes a little bit more obvious.
Yes.
Okay. Any other questions then?
That was helpful.
Yeah. I like questions because this is the kind of thing I'd like, like tomorrow, where, oh yeah, that makes that question a lot easier. It helps everyone. Do we have any more questions from anybody? I'm assuming people are hanging about because they might want to talk to me, but not in front of the rest of you, which I can totally understand.
Yeah,
I don't care if Travis and Brooke are here observing. It doesn't bother me.
Okay, so if it doesn't bother, yeah, whoever wants to start talking, start talking. And if you want to wait to the end on your own, then you just hang about until everybody else is gone and we can do whatever it is then. So what's your question, Lindsay?
First, Travis and Brooke, did you guys ask everything you wanted to?
Oh yeah, I just stick around for homework questions.
Okay. I have some questions from 16.7. Can I have screen sharing privileges, please?
You can indeed.
Okay.
I haven't got there yet, but I will.
No worries.
Okay, I'm having window problems. Okay, come on, share. How hard is it to share? It's not letting me share. What am I doing wrong? It's normally just hit a button and we're good. Right, I'm hitting share. There we go. It was just weird. There we go. You got permission.
There we go. Okay, perfect. For one, I just wanted to ask, can you tell me the answer for number 1 in 16.7? I made, I think, a really dumb mistake doing it the first time, and
Okay.
by the time I figured out where I went wrong, I'd used 3 tries.
I got you. Well, I'm trying to, but the window's not opening up. Let me do it again. There it is. No, I'll close that window then. I'll try. I've got about 5 windows open. So this window, no, I'll close that one. Okay, I'm down to 3 windows, so it must be one of them. There we go. The video is still running. That might be causing the problem. So we're in here. Hopefully that'll work. It was 16.7, you said?
Yeah.
And let's see. Why can't I find your name? Last name.
Miller.
God, my eye. Well, the screen's kind of small, so I'll blame that. And it was question 1, right? I got you. So we're kicking on that. Ooh. The right answer is 1408 over 3 square root of 14.
Okay.
So it looks like the number part, everything, all the other 2 bits were right, but the number part should be 1408.
Yeah, and when I calculated it again, because it really like offended me to miss one of these really early ones, I finally got the 1408 divided by 3. I don't even know how I. Okay.
Well, I don't know how you make mistakes, because I've never made any mistakes ever.
Okay, I have like 3 questions from this section.
Okay, who's the next one?
Number 4, which is this awful looking thing.
Oh, yeah, it is awful. You're right.
Yeah, this one was bad. So I did it. First, I integrated with respect to y. So would you just say it's better to switch your order of integration and do it with respect to x at first?
And the way this question is looking and the symmetry that this question's going, I would say it shouldn't make any difference at all. I mean, either would be equally hard or equally ugly. I don't think that there's a preference to that one. I'll look up what they did in the solution to that question, and that was, oh, come on, Windows. I've just been timed out, would you believe? I don't know why they think I need to get timed out.
That
Am I
is,
going to do?
yeah, it's really annoying how quickly they will time you out. Like,
Yeah, you're not watching it. They just, then you in your case, you'll go back in, it'll be a different question because it'll update the questions, won't it?
well, usually no, it doesn't do that.
Oh, that's at least something then.
And also I've noticed that if I am in another tab, like what I'll do is just switch to another tab and then it won't time me out.
Okay, so you found a workaround for it.
Like, then why even time me out in the first place? Like, just stop, but whatever.
Yeah. So I've forgotten the number. This is in 16.7?
Yeah, number 4.
And it's, right, finally got in and loaded up. So I'm going to look at its solution to number 4 and see what it is doing. Should do it under view, I guess. It's taking its time loading up. Okay, got 4. Click a view solution. Oh, I see. Yeah. The integral was y ds. Okay. I guess that would make a difference. But they did x and then they did y.
Okay, and so they did switch that order of integration. What is the actual answer?
The actual answer is some really, really ugly number. If you give me permission, I'll show you it.
Sure.
Okay. So I'm going to go, yes. Okay. So I'm going to go in, and this is it here. I'll make it a bit bigger. There. Oh God. It just as ugly as you thought it was going to be, just maybe a different
I'm
ugly.
not seeing it yet. It says you started
Oh.
screen sharing, but it's not displaying anything.
Okay, let's try it again.
There we go. Oh wait.
What? Did it? Yeah. Is it on now?
It says you've started screen sharing, and I should double click to enter full screen mode. But I
Well,
am
you
not.
do what it says, and then I'll try another picture. If that one doesn't work, I've got another version of it down here. Did that work? I'm trying to share the
There
screen.
we go. Okay, so it is just. I wonder if I made an arithmetic error in there and like.
It wouldn't surprise me when I just look at some of the numbers that are floating around in there.
Okay, well, yeah, that problem sucked.
Right. I mean, yes, not arguing with that. It does. If you look at just this one little piece here, that's really 11 cubed square root 11. So I'm assuming that 11 cubed is some kind of ugly answer. But if that wasn't bad enough, don't they then do a 2/7 of it?
I wonder if like I just did not input it the way they wanted or something.
You'd have to look at that answer if you take a copy of it or a screenshot or something. Plug it into your calculator, maybe round it off to 3 decimal places, and then take your answer and plug it into a calculator and round it off to 3 decimal places. If it's the same answer numerically, then you just found a different version of it. That's the easiest way to do a check on. Is mine equivalent to theirs?
Oh wait, I think their limits of integration might be different too, because they're going from 11 to 6. And I think mine were from unless they change the limits of integration.
Well, it looks like because you're doing X and Y, the X's go from 0 to 5 and so do the Y's, so there isn't any change in limits. The reason why there's a change down here is because they did a U sub. Right, so to solve this fella here, what did they do here? Well, they integrated this guy first, and then they did a U sub later. So that's essentially what they did here.
Well, it sounds like my approach was right, because that's what I did too, basically.
Right. So it's more likely a number issue than a process issue.
Yeah, well, that's good at least. That's some consolation to missing that one. Okay, and then the last one I missed, I think I just did not flip the sign at the end when I should have. So
Is it an answer you want to check?
Please, to number 7.
On 16.7 still?
Yes, and then I have one more question after that.
That's it. 7.16.7. And it's a sign, just like you said.
Okay, great. And then I would like to ask one question from 16.8.
Okay, I'll have to get out of this one. Unless it's something you can just tell me because it's easy to say.
It might be easier to look at it, and I can share the screen.
Well, yeah, you share your screen. It's probably going to be less hassle for me as well.
Okay.
And other people can see it quicker than me jumping in and out.
Okay. So we're using Stokes' theorem to evaluate this, and I always get screwed up when it is a cone like this, and especially because this cone is x equals yada yada. And I was wondering if it was one of those situations like we discussed today where
it is. That's exactly what it is. So what you have to, so what you're going to think about here is that the x stays put, and the y is r cos theta, and the z is r sin theta. And using cylindrical coordinates.
So using my rule, wouldn't the x bound be x is equal to r
Well,
with
no.
that square
So
root over it, or no?
well, in this case, the x's are 0 to 3.
Okay.
And the y's and the z's will turn into y will become r cos theta and z will be r sin theta.
Okay.
That would be
Y is
that would
R
be the
sin.
that would be the natural orientation for that question.
So
Um,
X equals
So yeah,
basically.
so you're basically doing a polar.
And then
Okay.
it would become dx dr or r dr d theta.
Well, because in this question, if we were doing it today's method, that's exactly how you would have done this question. But since we're using their method, what you would do is that you would do the parametric version of that guy, and the parametric version of that guy wouldn't that simply be, where are we? I've got it in front of me here. What have they got? Yeah, let me show you. It's quicker to show you than to try and say it because I've got a lot going on in here. So I'm going to stop that again. I think it's on this picture here. Are you looking at question 2 solution?
Mm-hmm.
Okay, so what they've got is that you're trying to find the boundary of this surface described in this way. And the boundary of this guy with x equals 4, I know that orientation doesn't matter. This fella here is 4 because of the x. And then you're doing the y. Instead of 4 cosine theta and 4 sine theta, we're just calling them t's. You know that when you do a single parametric curve, they're like t rather than theta. So y is r cos theta becomes y is 4 cosine t, and z is 4 sine theta becomes 4 sine t. So there is your parametric. The x is 4 because of that. The y is 4 cosine t, and the z is 4 sine t, and that's basically using polar on that relationship there. So I don't need the thetas. My mind is still on divergence theorem. In fact, if I did divergence theorem, I would have got the answer 0 easier, because I believe that function up here has a 0 divergence. I'm also pretty sure that this function up here, the one called f, is a conservative field. And since this is a closed loop, wouldn't the answer be 0 for that reason? And so there's a, yeah, so that would be a closed loop on a conservative field. There are lots of reasons why that answer would be 0, but that in particular, that's the math that you would have used if the answer hadn't been 0 anyway. Right. The parametric equation of this circle at a height of 4, orientated in the YZ plane direction, is 4 for the x's, 4 cosine t for the y's, and 4 sine t for the z's. And then the rest is pretty much derivative r dashed. Change all the x, y's, and z's up here into either a 4 if you're an x, a 4 cosine t if you're a y, and a 4 sine t if you're a z.